To understand the current AI boom's scale, we must look at power consumption. This graphic compares a standard data center to the massive 1 gigawatt AI campuses under construction. That footprint draws the equivalent output of a nuclear reactor. Training modern artificial intelligence requires scaling up computing capacity at a breakneck pace. Tech leaders at AWS, Meta, and xAI, founded by Elon Musk, are pouring billions into deploying this massive new infrastructure. But Silicon Valley is used to iterating in code. You write a program, hit deploy, and it scales instantly. AI, on the other hand, lives on heavy physical servers, and that physical reality is causing severe bottlenecks. This bar chart visualizes the pipeline of AI data centers due this year. Satellite data from SynMax shows nearly 40% risk missing deadlines. Looking ahead to next year, over 60% of planned facilities haven't even broken ground. You can raise $1 trillion for artificial intelligence, but that capital is colliding directly with the hard limitations of mixing concrete and laying steel. To see exactly where the disconnect lies, we can look at the massive new developments rising in Texas, specifically the mega campuses in Shackelford and Milam counties. Publicly, the companies developing these sites are projecting extreme confidence. Oracle has stated their developments are moving forward on time, while OpenAI recently claimed their massive build-out is entirely on schedule. The view from space tells a different story. Look at this simulated satellite map of the 1,200-acre Shackelford site. Out of 10 promised facilities, current intelligence shows active development on exactly one. The group constructing the site expects the first building to be delivered in the second half of 2026. However, based on standard industry construction benchmarks, independent estimates project that timeline is likely slipping toward late 2027. So, if the financing is there, what exactly is failing on the ground? Supply chains are backlogged, requiring multi-year waits to secure critical physical components like gas turbines and massive power transformers. The electrical grids themselves are already straining. They were never built to accommodate a sudden gigawatt-scale power draw. A company can execute a software update overnight, but no amount of venture capital can force a factory to smelt copper or manufacture industrial power grid infrastructure any faster. A secondary bottleneck is appearing in the workforce. When hyperscalers rush to build multiple massive clusters in the exact same region, they run out of the qualified people needed to build them. It creates a bizarre economic loop where a company like OpenAI ends up effectively competing against itself for labor across its various Texas sites. This flowchart maps how a fixed pool of specialist labor, like electricians and pipe fitters, operates. By hopping between competing projects for better pay, these workers drive local labor costs up by 30%, while overall construction progress stalls. Construction executives point out that even if you authorize double shifts for everyone who stays, there simply aren't enough human hours available to meet these aggressive tech timelines. Then there is the final unpredictable variable, local zoning. Take the neo-cloud provider Nebius, which struck a deal to build a 300-megawatt facility for Microsoft in Vineland, New Jersey. While the physical structures appear finished, this thermal imaging overlay reveals the actual status. The cold, dark equipment blocks prove the servers inside have not yet come online. The Vineland project has faced formal requests for public comment and local community resistance. You cannot simply apply the Silicon Valley ethos of moving fast and breaking things when you have to clear local municipal planning boards. Every month a data center sits empty or waiting for a permit, the financial models for these tech giants take a direct hit. We can see the problem in this graph showing the expanding revenue gap. Companies are spending billions upfront on massive AI chip orders, but because the buildings to house them aren't ready, the timeline to actually generate returns stretches further out. The cloud is ultimately made of physical concrete and human labor and remains completely bound by the weight of heavy logistics. Data center executives are raising the alarm. Securing the financing, managing the logistics, and running operations at this massive gigawatt scale are incredibly difficult tasks. As the year progresses, the tech industry is bracing for high-profile delays. The race to build artificial intelligence has finally hit the absolute speed limit of physical human construction.